Now I right click the property boundary poly layer. Notice that it has both geographic and projected system coordinate system. The projected system is the GWC Projected Coordinate System WGC 1984 UTM Zone 10 North. So that's the spatial information, and we're going to close the property window. In the geoprocessing pane, we're going to find the project raster tool in the data management tool set. So we're going to open the toolbox, and we will do select project raster, and open the tool. Make center a little bit, and for input layer we're going to click net property, and for output raster data, maintain the default location but scroll to the end for the path inside of the box and replace the default name extract net 1 output raster extract net underscore 1 underscore project raster. It's a long name. Oh no, it's NAD project. Shoot, NAD project. So for output coordinate system, we're going to scroll down and choose the property boundary, and it will automatically load this layer for us, import from its coordinate system. Nearest neighbor, that's fine, and we leave other thing and we just run the tool. And so for the optional parameters, we could learn more about the tool tips later. Now it's perfect. It's projected, and we're going to remove the net property layer from the map. Net property, and then net property output net project. We're going to close this out. What remains is the elevation raster clipped to the extent to the study area and projected appropriately. We're going to save everything and continue. Save. And we're going to derive new surface. So we learn a little bit about precision agriculture techniques. We're going to create aspect surface to determine which areas of the property are south-facing, the preferred aspect for a vineyard. And we're going to create a slope surface to determine which areas of the property have a slope measurements of 14% slope or less, required for machine harvesting, and create 3 hill shade surfaces using almanac value for sun altitude and azimuth to determine which areas are in sun with minimal shades at 3 different times of the afternoon in mid-September. Longer sun ripen just before harvest is ideal. Overlay polygon features that show which areas are already planted to reveal the areas that are available for a new vineyard. Assess the suitability of these areas based on your aspect, slope, and hill shade layers. We're going to derive an aspect surface. So we're going to continue working on this vineyard project. We assume that everything is here. We're going to name this, let's just resave as them. Vineyard, we're going to name it suitability and click save. And the original two elevation rasters have been reduced to the extent of the property boundary, the project study area. It was appended to a single raster. The appended is not working, but we use this combine and projected into a local coordinate system. The project includes a folder connection to the project folder, and the geoprocessing history reflects the work we have done so far. So, we can, we're going to analyze, let's see, suitability. Yeah, it's suitability. And let's see if, oh, there was a result. Actually, we could use, let me drag it to the side. Getting to know Vineyard, and it's in results, Vineyard B, and this is the one we could use. But anyway, they prepared the data for us. Let's just try it and see what was the issue here. But first, we're going to analyze the aspect of the topography, the ground surface relief, to determine which direction, which part of the ground primarily face north, south, east, west, or in between. We're going to use the geoprocessing tool and search aspect. So then we have a tool and we spatial analysis tool. So aspect tool in the 3D analysis toolbox is the same tool. There is a quite bit of overlap between spatial analysis and 3D toolboxes. So this workflow can be accomplished using either extension. Okay, for our input raster, we're going to click NAD project. And output raster, just leave it aspect NAD. That's fine. Let's just do aspect NAD. And then we're going to run the tool, leave everything as it is. When processing is complete, we're going to examine. That's really nice color. And we're going to right click on it and just do zoom to layer. And we do have some result. So examine the result. Notice in particular the area that faces south, north, southeast, and southwest. Next, we will derive the slope layer. To derive the slope surface, we're going to go to Tools and search for Slope. And the same way, we will do Spatial Analysis tool. And for Input Raster, we're going to click NAD Project. And for Output, we will just do Slope NAD. And change the output measurement to percent rise, and method is just keep it. And then we're going to run the tool. So let's double check. So for input raster, we had NAD project. For output raster, we maintained the default location, but we added the name the name to slope NAD. We changed the output measurement to percent rise. So percent theta, and we maintain the default Z factor, and we going to run the tool. And that's our slope. When processing is complete, we examine the results. We are interested in seeing only whether the slope is less than or greater than 14%, so we will symbolize the layer to have only these two categories. With slope NAD, we're going to select the context pane and then open the symbology pane. Right click on it and go to symbology. And we don't need this anymore. And we're going to do appearance. We could do from here appearance and then go to symbology or right click on symbology. The symbology pane, we're going to change the number of classes into 2. Classify or number of classes into 2. Perfect. And the field, why it's no field? Manual. Okay, manual classes. Oh, we cannot change it into 2. Alright. What did I did? Go to symbology again. Method. Oh no. I totally messed up. SlopeNet. Property. Not property. Right click on it. Symbology. Okay, we're going to change it into 2. Go to classify again. And method. It didn't show me 2. Alright. That's really weird. Okay. Something wrong must happen here. Classify. Let me close it out. Right click on it and symbology and is it classify? Unique values, it should be classify. And we will do 2 classes. Let's just remove this and we will re-add it. Remove and add data. Okay. Slope Ned. Click OK. And then symbology. Symbology. Stretch. Symbology. We're going to do classify. Alright. We will do 2 classes. And we will do upper value red to green, right? Red to green, and upper value we're going to type 14. 14. Click OK. There. 14. And menu interval. Alright. So we have it. Okay. So at the bottom of the map, under class breaks, we click the first upper value box once to select it, and click again to make it addable. Replace the existing value with 14, and then we press enter. Notice that when we change the class break values, the classification method changes from the default natural breaks to menu interval. We messed up a little bit earlier, but you can just remove the layer and re-add it and change the symbology. We're going to choose the symbology tab and see that although much of the property meets the criteria of having a slope that is less than or equal to 14%, a fair amount of it still has a greater percentage rise, which is not ideal for a new machine harvestable vineyard. And now we're going to derive a hue shade surface. A hue shade is a surface layer that depicts shadows to model the effect of an illumination source, usually the sun over the terrain of the land. To create a hue shade, we must enter an azimuth and altitude value. Azimuth is the distance of the sun expressed in positive degrees from 0 to 360, measured clockwise from north. The default azimuth is 315 degrees. Altitude is the is the angle of the sun above the horizon. The altitude is expressed in positive degrees with 0 degrees at the